You're not on camera. It's okay. Thank you. Thank you.
All right. So here we're looking at weighted averages. It says a survey asked students how many children are in their household. Complete the table to compute the average number of children per household. So you see there are only 4 problems in this section. So we'll look at the first 2. Like I said, try not to do all of your homework problems for you. But this first one says we have 0 children. And so when we talk about weighted average, you know, we talked about, did we do that in this class? Well, I'll go back. Let me go to my notes just to make sure. Where's my share button? Somebody eating some cereal or something? Somebody crunching in the mic? So if you want to take your average, just a regular average, let me write that A better. You add all data values. Then you divide. So if you're just talking about taking your average in a regular way, you're going to add up all your data values, divide by the number of data values. So if I have a data set, one, two, three, four, five, those are my numbers. If I want to calculate the average, I would just add them all together. Divide by the number of data values, which is 5. So 15 divided by 5 is 3. So the average would be 3. So we're just talking about the number of data, just taking the average without any weights to it. That's how you would do the average. It's just your general taking the average. You add up all your data values, divide by the number of data values. All right, anybody any problems with just your regular average? All right. Just make sure everybody's done copying before I turn the page. So when you're talking about weighted averages, well, you'll see in a second. I'll wait for everybody to.
Does it usually get more complex than this?
Well, we're about to look at weighted average, which adds one more.
Okay, one more step to it.
Yeah, one more step to it.
Okay.
So basically, you see how each one of our data values, when you're talking about a weighted average, each one of our data values are accounted for one time.
Okay.
So when you have a weighted average, that means some of your data values may be counted more than once. You know, or let's say, in other words, I have 3 values that that come in at 4. I have 6 values that come in at 5. So, you know, when we look at this next example, or this first example in your homework.
Okay.
All right, your frequency is how many times that value occurs. So we're looking at, oh, hold up. You guys don't see the screen, I don't think. Oh, no, I did share it. You guys can see the homework screen from my math lab?
Mm-hmm.
Okay,
yeah.
okay, good. I thought I didn't share it. So great. Thank you. So a survey asked students how many children are in their household. Complete the table to compute the average number of children per household. So 2 people said that they have 0 children. So 2, or that frequency column, lets you know how many times people answered those numbers on the left. So 6 people said they have 1 children. 11 people said they have 2 children. 2 children. 3 people said they have 3 children. 3 people said they have 4 children, and then 1 said they had 5. So you see, frequency is the number of times that the number on the left appeared. Is everybody okay with that? So when you say how many times does something frequently occur? In this case, 0 occurred 2 times.
Okay.
Product is multiplication.
Okay.
So that means in this first column, 0
okay.
times 2 is 0. 6 times 1, 6. 2 times 11, 22. And they should be walking us through the process in this first one. That's going to be 12. This will be 5. And we should have more right. So questions on that first step, we multiplied the frequency times the result that we got from the survey. And that's that first column that they ask of us. Well, I guess it'll be the third column in the table, but it's what they ask of us, the first column that they ask of us.
So far, no. So far, that was pretty good. Like, it wasn't that hard. Okay, I got that. Okay.
Now, sum means addition. And where's my calculator? So we got 2, 6, that's 8, 19, 26.
Okay, we're just going down the line then and adding all of that together.
Mm-hmm. Mm-hmm.
You don't divide the frequency number by the total number that's in the column.
Well, we're going by the steps that they're giving us, though. Yeah. So this example or this problem is asking you step by step,
Right.
you know, what they want you to do or what you should do. But that is going to be a part of the process. In the next problem, if I'm not mistaken, they're not going to ask you step by step like this. All right, so I feel like messing with this. Yep, that's 54. So let's see, average number of children per household is. So we should be able to, and I believe this is what your classmate was alluding to. We would take the product sum and divide it by that frequency sum. All right, so average number of children per household is, type in integer or simplified fraction. So that's going to be 54 over the 26. And just to show you the breakdown. I think that's good enough. Hold on. 54. Just making sure I didn't do something wrong the first time. And it was 54 and 26. Yep. So it should be just 27 over 3. I mean 13, excuse me. I didn't share my screen again. But yeah, it was 27 over the 13. So when they say they wanted you to type it, make sure you pay attention to the directions. Type as an integer or simplified fraction. So the fraction was 54 over the 26. They both were divisible by 2, so 27 over 13.
Okay.
All right. Questions. Okay, they do change the numbers. All right.
Somebody's mic is not muted. I think it's
Okay. If your mic isn't muted, please go ahead and mute that. Some people may be getting a feedback. So make sure you mute that for us. All right. Appreciate it. All right. So let's look at the next one. Like I said, this is the second one out of the 4 problems. So I'll try to leave the other 2 for you to knock out. Of course, if you have any questions on them, make sure you ask. All right. So this next one. Your GPA is weighted average. Your grades are weighted by the credits for each course. Quality points are the product of the credits for a course and 4.0 scale of your grades. All right, so a C gives you 2 points and it's 4 credits. So in this first column on the quality points, we'll be doing 4 times 2, which should be 8. So you have 4 credits. 4 times the 2 is weighted at 4. Same thing here, 4 times 3 will be 12. And then the next one, you got 3.67 because you got an A minus. 3.67 times 3. So that's 11, whoa, 11.01. All right, everybody good with that? All right, so the GPA for your course is going to be, we're going to add up our quality points, add up our credits, and divide the sum of the quality points by the sum of the credits, just like we did last time. It's just that they're not giving us that as a step. All right. Ooh, let me take a picture of this and then go back to our notes page. All right, so quality points, we had 8, 12, 11.1, and that's what, 31.1, 0.01, excuse me, I said 0.1. And then the other one was 4, 4, and 3. Sorry, credits, 4, 4, 3. That's 11. GPA, 31.01 divided by 11. 2.819. All right, so before I go to the homework, make sure I didn't miscalculate anything. Questions on what I did. It's the same process that we did in the last problem. It's just that they didn't do the step-by-step in each, for each piece.
what's the 2 for behind the GPA?
You said the 2? Yeah, that's not a 2. It's an equal sign. Sorry about that. That was me being lazy. Sorry about that. All right. Questions? Everybody good? Everybody good?
Pretty good.
All right. So let's go back. Like I said, I always like to make sure I didn't miscalculate anything. Type an integer or decimal rounded to the nearest hundredth as needed. So it's 2.82. All right. So we good to go. So like I said, try it out. Those steps should be what you will be trying to follow as you progress throughout your many problems of 4 in this section. All right. Let's see, that's 2.2. I'm going to check 2.3. We can start 2.3. Oh, let me do one more thing before. All right. All right, so 2.3 is proportionality. Direct proportion is when one value increases, the other increases. Inverse proportion is when one value increases, the other decreases. I ain't give myself enough room. All right, so the first type of setup, looking at direct proportion, y is directly proportional to x, or y varies directly as x, is going to be y equal to kx. K is your constant of variation. And hold on, I think this book Wait, this text calls it. Okay. Constant. Constant of proportionality. All right. So that K, no matter what setup you're looking at, whether it's direct variation or the direct proportion. I should say direct variation, same thing though. We look whether you're looking at direct or inverse variation, you will have a constant that K will be a part of your setup. Oh, also, I meant to mention it. Yeah, the keyword directly, which lets you know that this is the formula you'll use. So just like in the next relationship, we're looking at inverse proportion or inverse variation. You'll see the keyword of inverse, which will let us know to use the next setup. All right, so your inverse proportion, y varies, or y is inversely proportional to x, or y varies inversely as x. It's y equal to k over x. And k, once again, is that constant of proportionality. All right. About to switch screens. Everybody good? All right. First problem in 2.3. For each of the pairs of quantities, identify if they are directly, inversely, or not proportional. So remember, directly means that when one increases, the other one increases. Inversely means when one increases, the other one decreases. And if there's no relationship at all, then you would do or choose not proportional. So very similar to the way a lot of problems, or not a lot of problems, a lot of exercises start off. They start off with getting you guys acclimated to the terminology and the concept. So here we have tax, the amount charged for buying an item is going to be inversely, directly, or not proportional to the cost of an item. So if the tax increases, that means the cost increases, or vice versa. As the cost increases, the tax increases. So that means they are directly proportional. Like the tax on the item doesn't go down if your cost increases. It goes up with the cost. Population of a region. In other words, the amount of people that live in a region is how proportional to the region itself, the area of the region. Should be not proportional because I don't care how many people you put in Chesapeake, the area is not going to grow. Yeah, so it's not proportional. Questions on the first two? Pretty good.
Yeah, pretty good.
All right. Yep. Just got to sit back and think about, think about it a little bit. Do this one and then we'll go to another one. It says average speed to work, time it takes. So if you increase your speed, the time it takes would decrease. So it should be inversely proportional. All right. So that's how you should be thinking about those type of problems. For number one, just okay, if I increase one, what happens to the other? All right, that's a good next one. Okay, so number of miles driven is proportional to the gas the car uses. Note that the driving is assumed to be consistent over time. Complete parts A and B. All right, so for two proportional quantities, the decimal equivalent of the fraction represented of their ratio is called, so we already talked about that. That's the constant. That's the thing that's going to be constant, the number that's going to be constant throughout this whole relationship. So they call it the constant of proportionality. All right, assuming that a person drives 135 miles on 5 gallons of gas, both constants of proportionality express the first as whole numbers, second fraction, and lowest terms. All right. .7. I need to see if they got my books fixed. My book fixed. All right. So what I did here, it says that assuming that a person drives 135 miles on 5 gallons of gas, I believe we talked about proportional. What at my other class? We talked about proportion in this class. Yeah. I think so. Ratios, rates, and proportions.
Yeah.
So 135 over the 5 gallons, 135 miles per 5 gallons. So 135 divided by 5 is 27. And so that's where that 27 came from. And then the constant of proportionality expressed as a fraction. I'm assuming they want the 27 over 1. Okay, constant of proportionality expressed as a fraction. So what am I missing? That's the constant of proportionality expressed as a whole number. Constant of proportionality expressed as a fraction. That is my 27. I'm just going to do this and see what they're asking of x over y. 1 over 27, your answer is 27 over 1. Constant of proportionality expressed as a fraction. So let me do this. But why did they ask for it as x? So this is what's going on here. Hold on, let me look at one thing before I go back to that. So that should be okay. So, go back to my screen. All right. All right, so it says the number of miles driven is proportional to the gas the car uses. And I'm seeing a direct proportion here because the more miles you drive, the more gas you use. So it's not an inverse proportion. So in other words, let's call X, I'll call this Y. Miles driven X gas car uses. Now also keep in mind, make sure you pay attention to the wording. So the number of miles driven is proportional to the gas the car uses. So once again, to me, that's a direct proportion. Now, if it said the number of miles driven is proportional to the gas that the car has in the tank, then it would be inverse, because the more miles you drive, the less gas you will have in your tank. So make sure you pay attention to the wording, because that will dictate whether you use direct proportion versus inverse. So if I do y, kx, said our constant of proportion was 135 over 5, which is 27. So I should be able to write this problem this way. So now I'm trying to see why they want me to write it as 1 over 27. So now if I were to solve this for x, divide both sides by 27, then I would have 127 y equal to x. So let me check one thing. The relationship between proportions is represented by, right, that's what we did, k is a constant. Next. Okay, do so. So use the right thing. Yeah, that's just, okay, that's just what they wanted. Constant proportionality, general constant. Solve for x. Trying to see what in the directions. Constant proportionality expressed as a whole number, constant of proportionality expressed as a fraction. Consists over time, parts A and B. Well, I don't see anything in the directions that told me to do it, but that's what they wanted. So the first part, like I showed you, is this. That's how we got the 27. And this is where I thought they got the 1 over 27 from. They put it in the formula that I gave you initially for the direct proportion. Then they solved it for x. And whatever you solve for x, that's the next piece that they want from you in this problem. So going back. So yeah, so that's why we have 27 here for B and then 1 over 27 for the second part of B. That's solving your direct proportion relationship for X. And so doing that, so both of those should be inverses of each other. So you can just keep it like that. In other words, if I had 3/4 for the first part, then for the second part, I have 4/3. Questions on the relationship between those two? Before we look at another one. Okay. A cup of flour. All right, let me take a picture of this and then we'll do it. All right, so let's try this one out. All right, so we have a recipe for 16 banana nut muffins. Calls for 1 cup of flour. The number of muffins that can be made varies directly with the amount of flour used. There are 2.5 cups of flour. How many muffins can be made? All right. So now before somebody asks, yes, there is another way of doing it. I'm just teaching the way that you're talking about in this section. But yes, you can set up another type of proportion and do it another way. But like I said, we're just talking about this method right here. All right. So let's look at some steps here. All right, so the first thing we want to do is establish which relationship to use. And so we're looking at varies directly. So we know we're going to look at this type of setup. Y equal to K times X. All right, next we're going to look at establishing what variables to use. And what I mean by that is that we can use Y and X if you want, and that's fine. But just establish that. So the way we would do it is that whatever's in front of varies directly is your first variable. Whatever's after that is your second variable. Remember, the setup was Y varies directly to X. So Y is going to be whatever's in front of the phrase varies directly. So it says the number of muffins that can be made. So you can call it N if you like. Or if you, like I said, if you want to leave it at Y, that's fine. All right, so N is the number of muffins that can be made. And I'll come back down to it. And varies directly to the amount of flour used. You can call that A. Or you could have called it M for muffins, F for flour. You know, it doesn't matter. So if I'm going to use N and A, that's going to be N equal to K times A. And I want to stay consistent, so I'll turn that purple. All right, so let's now establish our given information. So when we look at what we are initially given, we have for 16 banana nut muffins, 1 cup of flour. So the first number of muffins that we are given and the first amount, 16 to 1. Then we're going to have a second amount and a second number of muffins. So it says how many muffins that can be made. That's our unknown when you have 2.5 cups of flour. That is the amount of flour, right? So probably been better if I called it muffins and flour. Oh, this. All right, and this is how all of them will be set up. They will give you all of your first set of information or your first relationship, the number of muffins and the amount of flour. 16 muffins is equal to 1 cup of flour. Then they will give you everything except for one piece of information, and then you will use the relationship to find that one piece of information. All right, so the next step is to find K. So it wants to find the next step is to find the constant of proportionality. So our relationship is N equal to K times A. And so what we're going to do is use this first set of information to figure out what K is. Now remember, K is called your constant of proportionality. That means it's going to be constant throughout the whole problem. So once you find K, that's going to stay K. That number will stay the same throughout the problem. So that's 16 for N, K. We don't know. A is 1. And that works out well for us because K times 1 is just K. So that means K is equal to 16. So now we can actually insert K into the relationship. So now if we know the amount of flour that we have, we can plug it into the relationship and figure out how many muffins we could create. So the last step is find the missing piece of information. The A that we know, A2 is 2.5. So that'd be 16 times 2.5. And that would be 40. All right. Questions? All right. Let's do at least one more. But before I go there, so if you follow those 6 steps, even if it was inverse, then you would start off with y equal to k over x, and then you would just follow these same steps. All right, so let's look at all right, the distance d, you bike varies. That should be your bike. Okay, the distance your bike varies directly with the amount of time t you bike. T you bike? Is it you? Seems like you should say your, but okay, you did it twice. So suppose you bike 9.6 and 1.25. What is the equation that relates to D and T? Okay, so this is just helping us with concept again. It says the distance. Okay, so they want us to find what K is. So I'll take a picture of this and then write it out. All right. Come on. So they established the variables for us. This time they gave us D for distance. The distance D you bike. The distance D. I don't know. I don't know if it's supposed to be your or you or what, but it just sounds funny. Okay, the distance. Right. All right. It has to be the distance D you ride your bike. It has to be, they has to be missing a lot of words in there somewhere. So suppose you ride your bike, you know, something like that. So, but we should be able to get the gist of it though. All right, the distance D, your bike varies directly with the, well, we already went through that. Suppose your bike 9.6 miles, you ride your bike 9.6 miles in an hour and 25, or 1.25 hours. What is the equation that relates to D and T? So first we know that there's a direct relationship. So if it varies directly, and notice that D comes before your phrasing. So D is written first, and this is going to be equal to KT. So that should be the relationship that you have. Now they have a number sitting for all of the options. If you go back to the problem, show you what it looks like so you can see what they're asking of you. All of the options over here is D equal to a number times T. So really what all they want us to find in this problem is what is K, and then plug it into your formula. So we have 9.6 miles, which is going to be your distance, and your time, T, is 1.25 hours. So you do 9.6 equal to K times 1.25. Divide by 1.25. K is equal to 7.68. Oh, let's do that. And that was the last option down there. So all right. Questions on that?
No.
And if you were to go back to it, where it go, right there. Then they also ask you to graph it. So make sure you have a graphing tool. You can always Google graphing calculator or something like that. A bunch of free stuff out there. Just make sure that when you look at when you're graphing, look at the scale. Notice you have 0 to 5 on the bottom, 0 to 30 on your vertical axis. So your horizontal axis is going from 0 to 5. Vertical axis is going from 0 to 30. So they give you those scales so that you can graph accordingly and get that graph that they have up here. If you're doing X and Y, D is going to be your Y, T will be your X. So they're showing you all that. So just make sure you do it accordingly. I'm not asking you to do it by hand, but make sure you have something that's reliable that can graph it for you. And if you don't know how to use your graphing calculator or whatever, then just make sure you hit me up so I can, we can meet in a Zoom. I can show you how to do it. I'm gonna take a guess here. We got 0.768.
And that's what they're wanting us to graph is the 7.68, right?
Yeah, the D equal to 7.68. So when you're talking about just a regular, let's say a TI, then that means Y is equal to 7.68X. because y is d and t is x.
Oh,
Yeah, so that's what you have to put in your calculator. Y equals 7.68 x. I'm thinking, let's see. Oh, hit the wrong button. What was that popped up? All right. Your answer. Hold up, I changed it to D. Oh, that sucks. I changed it to D. Okay.
I hate when that happens to me. I'm like, dang it. God.
Oh, well, yeah. So anyway,
Okay.
so that's how that goes. So try the stuff out, see if you get stuck. We're about out of time now. Got 5 minutes. But yeah, so try it out. See if you get stuck. If you have any problems, we can do some more. If you run across something that you have any questions with. And we'll go from there.
Awesome. Well, thank you for your time, and I will see you later on today at 4 for the tutoring session.
Got you. All right, not a problem. All right.
You guys have a good day. Good luck with everything.
You too.
You
Thank
too.
All right.
Bye,
You
guys.
too.
Have a good day.
All right.
See ya.
Everyone take care.
Yeah, you guys too. See you Wednesday.
Yep.
All right.
Bye, guys.
Have a fun day.
Bye.
Oh, you have a question. Wait, you have a
Yeah.
question.
I'm still here.
Okay.
All right.
It's just I guess we were supposed to meet yesterday. I don't
Okay.
know what happened.
Yeah. Did you ever confirm?
I sent the email. I said one was fine.
I never got that email.
Yes, you did because you responded to me.
Hold on. I might be confusing with somebody else. Did I ever send you? I have to look at those emails because I think. Hold on. Let me stop recording.
I said one. Oh yeah, sorry.
I'm not. You good? I mean, because of no point in holding on to.